Okay, so I think you guys have managed to look through most of the test. So any questions from the test? No? Before we go on? Okay, so again, a lot of you guys did really well on this test, and there's a lot of people passing this course with flying colors. The unfortunate thing about Math 90 is you don't get a letter grade. So a lot of people make A's, but it shows up the same as if you made a C. It shows up as that pass. But still, personally, if I were you, I'd still want to make as high of a grade. And I will always tell you exactly the grade you made. Or if you email me after the final, I'll tell you you made an A+, if I was able to give that to you. Right? I mean, it doesn't show up on your transcript, but you should still know I'm going to be that much better prepared for the next level of math. So any leftover questions from old homework? We still have 2 sections of 4 to do. I think from 4 up to 4.3. Is that all right?
We finished 4.3.
We did finish 4.3. So any questions on homework up through 4.3 before we move on? Okay. How you guys doing? Are you all right?
Yeah.
I know some of you guys might be a little bummed, but of course come see me if you made that low grade. I want to help you do your corrections so you can get as many points back. Yes, you can get help from me on your corrections. So that's always a damn good idea. Give me the test corrections and say, can you look these over real quick and tell me if I need to change any? And then I'll say, this and this one are still not right. There you go. Try to get as many points back as you can. Okay. So let's see what you guys think about this. And I should have brought my, any of you guys read the comics?
Yeah.
Yes? Any of you guys read Foxtrot? They went down to like 1 comic a week, which sucks. Because the writer is, the artist is taking some time off. I love Foxtrot. Anybody else know Foxtrot? With Paige and Jason and all the crazy people. So they love mathematical jokes. So obviously I would gravitate in that direction. But there was one problem where they were talking about, the girl in the comic is talking about she hates math. She doesn't understand math. And then the brother comes in and says, well, if you had 5 sweaters and 4 sneakers and it cost this much money, how much is each? And then she had the answer right there. Because she could put it, it was something she could relate to. Right? She obviously enjoyed shopping. Something I don't like, unless it's something else. Books, actually. So a problem like that would be something like this. Let me give you a problem. Let me just see what you guys think we can do with it. So here's a very nice, simple problem. 4 hot dogs and 5 orders of fries. Costs, let's say, $8.50.
What is this for?
This is for the next section.
Oh.
I didn't really want to say that yet, but I can say that. 4 hot dogs and 5 order of fries cost $8.50. And let's say 6 hot dogs and 3 order of fries costs, let's see, how much would that be, Jeff? $10.50. Now, if I only gave you one of these sentences, is that really enough information to figure out how much each one costs? Because 4 hot dogs and 5 fries cost $8.50. Well, the fries could have been free, and then the hot dogs would have cost $8.50 divided by 4. I mean, I don't know. There's too many. If the fries cost 25 cents each, and the hot dogs are going to cost whatever's left to make this. So how many variables do I really have in this whole problem? How many unknowns? Now, why do you say 4?
Because you have 2 different problems.
I have one problem with 2 pieces of information. This is the same little stand, right? So I'm at I'm obviously not at a ball game because it would be more expensive. I'm somewhere where it's pretty damn cheap, right? And so the same little concession stand, there's a little person behind the counter. Hey. So one person goes up there and gets 4 hot dogs and 5 fries, and they pay $8.50. The next one comes up and gets 6 dogs and 3 orders of fries, and that's $10.50. So it's at the same little stand. So it's not 2 separate problems, but I had to give you 2 pieces of information because there are 2 unknowns. What are those 2 unknowns?
The cost of fries.
Yeah, the cost of fries, and the cost of the hot dogs. So here's the nice thing with these problems. There's 2 main types of this problem that you'll see in this section. One of them is this one. And this is the one that's really nice. The problems kind of set themselves up. What would you want to call the cost of the French fries? What letter? I would use F. What about hot dogs? H. If you want to always use X and Y, feel free. But I would call it a letter that would kind of relate it directly to what the idea is. So I don't forget. When I get F equals 7 or something, I'll know what that means. The fries cost $7. Oh, God. It better be pretty damn good. So this first situation here, what's the equation I could set up there? Yeah, 4 hot dogs. So how much total money is that just for the hot dogs? It's 4 times H, because each hot dog is H dollars. So it'll be 4H plus 5F is $8.50. Do you see what I mean about the math is almost the same as this English sentence. 4 hot dogs and 5 fries costs $8.50. So the second equation, what would that look like?
6H plus 3F equals 1050.
Equals 1050. And then how do you think you solve that?
Substitution.
Yeah, you can use substitution, you can use elimination, whichever way you like. Do you guys see what I'm talking about? This is, once you set up the equation, or in this case, system of equations from our word problem, you just go back a couple sections and you see how to solve it. So you can use any method you want. I would not recommend graphical method. Right? I would either use elimination or substitution. So the interesting thing about number 2 is you could actually divide each of those by 3. Why would that be good? Why would it be good to be able to divide each of these by 3?
To get rid of fries, to no fries.
Well, I won't get rid of them. It'll make the coefficient 1. And then I could do, somebody said substitution method. It's really nice to use substitution when I don't get any fractions, right? So I can solve the second one for F. How would I use elimination?
Multiply by 3 and the second one by 5.
Exactly. So if you want to get rid of the F, what would the LCD be here? 15. So you want to multiply the first one by 3. Let's see, 24, 25, 50 maybe. And the second one you want to multiply by?
Negative 5.
-5, exactly, because you need to have them have opposite signs, right? So they'll actually cancel. So multiply the second one by -5, you'll get -30H minus 15F equals -5250. And now what's the next step there?
Cancel out.
Yeah, see, we've done that so that those two 15s will cancel each other out once I add them. So what do I get here? -18. -27. All right, keep going.
Divide by -18.
Divide by -18.
You get -1.5.
Well, you don't get negative, thank God.
Oh, see, that's what I got a lot wrong in the test.
If you get a negative here, that means they're paying you to eat their hot dogs. That, I'm going to live there.
Sounds like a good place.
Going to die early. Death from hot dogs. We have a lot of money to leave to my kids. No, it doesn't sound good. Maybe I'll rethink it. So, am I done there?
No.
I mean, the whole purpose here was it's a system of equations. I have two things I don't know.
No.
Hot dogs and fries. I got the hot dogs. Hot dogs are $1.50.
So plug it in.
So plug it in to figure out what the fries are, yeah. So, just like the word problems from before, they give us some setup in English. We got to translate it into an equation or system of equations in this case, and then I attack it with algebra, right? Make sure you answer the question all the way. So H is $1.50. If I put this in here, I get 6 plus 5F is 850. I get 5F is 250. So I get the fries cost 50 cents a pop. Cool? Do you guys see that? So obviously, if you have any trouble with substitution or elimination solving system of equations, you're going to hate this section because it's going to add on top of that, translate from English into math, right? But do you understand the word problems here are nowhere near as vague or as unclear as before? They really, this kind of problem definitely sets itself up. This problem sets itself up, yeah.
Would you still want us to make these a point, even though it's not X and Y?
No, here you don't really have to
That?
make it a point.
Okay.
I mean, technically it would be a point, but since we're tacking on the reality of these are hot dogs and these are fries, it sort of would be like the point fry, comma, hot dog, which is getting a little weird now.
Okay.
Right, so you can certainly leave this as fries are 50 cents, hot dogs are $1.50. Right, the graph of this is not important really.
Okay.
Not yet, it will be. You see my, oh, there. Okay, so I'm going to give you guys one to try just like this, yeah.
I just don't even know how you got 2550. You multiplied 3 times.
Oh, here.
Yeah.
I'm sorry. So yeah, times 3. So it'll be 12 plus 15, and then 850 times 3.
Okay.
Yeah. So 8 times 3 is 24. 50 cents times 3 is $1.50. 25.50. Yeah. So again, if you want to, you certainly can put a little 3 next to each of these, just to kind of follow what's going on. So here, you guys try this one. Let me take one right out of the book. Oh, all right. Here's one. This is 24 from page 279. It cost $1,203 back in 2008 for 8 tickets for Celine Dion. And 3 tickets for Kenny Chesney. That's an interesting combination. 4 tickets for Celine and 5 tickets for Chesney cost $857. I'm being a little evil. Let me give you guys a suggestion here. Okay. Do you guys get the setup? So if I got 8 tickets to Celine Dion, 3 tickets to Chesney, it's $1,203. Yeah, I've got that later on. And 4 tickets to Celine Dion and 5 tickets to Chesney cost $857. So obviously the question is, how much would a single ticket to each be? So try to set up that problem. This kind of problem is really kind of nice once you let it be. Define your variable. Change the English into math. And I'll stand up here and cross my fingers. signature to fill it out. Don't you? So he needs it back.
Right, one more. Right.
So tell him to come back to my office. I need it back. Okay.
Is this elimination or substitution?
Whatever you feel better. Whatever way seems to be a better way.
I got a negative answer, so I did something wrong.
That would be freaky. So let me catch up to you guys. I'm gonna call Celine Dion, I'm gonna call her price D, and I'm gonna call Kenny Chesney K. So, let me go over here. For this first sentence, how can I put this together into an equation?
8D plus
Good. 8D plus
3K
3K
equals $1,203.
equals $1,203. Alright, that kind of sucks. I got one color option for today. So the second situation would be the same idea. 4 Dion tickets plus 5 Kenny Chesney tickets would be $857. Now, just being able to set it up is half the problem. If now the problem is the large numbers, don't let that get you down. I let you use your calculator. It's crazy that I do that, but I do. All you got to figure out is what number do I want to multiply by. If you want to do elimination method, would you want to do substitution method? No, because not only do you get fractions, you get some really funky fractions, right? I don't want to solve for any of these variables because I'm going to end up with fractions. Yes, ma'am.
Could you times the bottom one by like a -2 and not have to do anything to the
I'd love it.
first one?
There you go.
Why didn't I do that?
So you could multiply by 5 and -3, but the easier LCD, is it okay if I say that? There's no denominators here, but it's the same idea, is to make both of these 8. That's already 8, so you want this one to be -8. So you multiply by -2. So this one you leave alone. And this one you multiply by -2. So if you put a little -2 next to each one, so you know what you're doing. -8D minus 10K equals
Negative
1734? 34? 14? Shoot. I was only
Okay, we
20
have
off.
calculators.
Yeah, that's a good thing. And now you've made them both 8, but now one of them's negative, so when you add them, this extra variable is going to go away. -7K. Well, equals, well, careful now. Yeah, -511. Yeah, you're right. Cool. You divide by -7. I like it. 73. There you go. So what does that mean right there by itself?
Kenny Chesney tickets are $73.
Kenny Chesney tickets cost $73. It's not done yet though because
Yep.
good. So that does have a meaning by itself, but I have 2 things I don't know. So now to figure out the other thing, I just plug 73 back in. Let's do this guy. 4D plus 5 times K, but we just figured out K is 73. A57. And I just got to solve that one for D. If you always want to use X and Y, that's fine. In fact, my D is probably not the best choice because now it looks like a 40 to me, but that's too bad for me. So now you subtract, what do you get there? 4D plus 365.
Mm-hmm.
Subtract 365.
492.
492, and then divide by 4.
123.
123. So Celine Dion cost $50 more ticket. Too much in my opinion, is right. That's me. Some of you guys might pay more than that to listen to Celine Dion, I don't know. Alright guys, do you see how that kind of problem sets itself up? 2 cats and 3 dogs cost $8. Okay, 2C plus 3D equals 8. You know, it sets itself up into an equation. It's a lot better than that first word problem section. A lot easier to set up the problems. It's not quite as wide-ranging. They got to be set up a certain way. Here's an example of the other kind of problem in this section. It's just a little bit harder. Let me see. Here we go, perfect. Number 17. This is page 278. Jonathan counted the money in his piggy bank. He had quarters and dimes. When he added up his money, he had 39 coins, worth a total of $7.50. This is very different, right? I'm going to end up with the system of equations, but it's not as direct as this was. When I look at the equation here, I can read it in English. 8 Celine Dion and 3 Kenny Chesney cost me $1,203. I can read the sentence, can't I? And that's exactly the sentence was presented to me in the problem. You with me? So the math to English is pretty direct translation. This one's not so direct. There are 2 main ideas. Somebody point out, what are the 2 main ideas, each of which get their own equation?
Quarters and dimes.
Those are the 2 players. Those are the 2 variables. So quarters I'll call obviously Q, and dimes I'll call amazingly enough D. Maybe I'll call it lowercase d. It's a little less like a 0. What does Q really represent, though? Let's be a little more specific. What does Q actually represent?
25 cents?
Each quarter is 25 cents, so that's not what I don't know. What does the letter Q represent? How many quarters? 11. So this is the number of quarters. So somewhere the 25 cents is going to come in, right? But by itself, Q is the number of quarters. Why? Because that's what I don't know. I don't know how many quarters there are. Because the little kid wouldn't tell me. Tell me. All right, dimes. Obviously, this will be D is the number of dimes. So you always have an easy equation. In this kind of problem, there's going to be a total equation, and in this case, a money equation. So there's a total of 39 coins. That's the easy-ass equation. Where does that 39 come from when you do what? How do you get the total number of coins? You add Q and D. So Q plus D must be 39. People always mix up the money with the number of things, right? Like if it was $5 for an adult and $3 for a kid, and there were 20 people, I can't say 5A plus 3K equals 20. I can't mix money with people. That's freaky. Right? I can't do that. I have people and I have money. I have number of coins, and now I throw in the money. Each quarter gives me how many dollars? Let me see if you guys can pick up on this.
4.
Each quarter.
Gives you a fourth of a dollar.
A fourth, so 25 cents, a 0.25. You wouldn't write this That would be $25. That's wishful thinking. So 0.25 for every quarter plus
0.10
0.10 for every dime. When you add that up, you should get 750. Do you start to see how that puts itself together? Not quite as easily as that. It's not a direct translation. But this still is, there's 39 total dimes and quarters. $750, 10 cents for each dime, 25 cents for each quarter. Right? Is that cool? It's not a direct translation anymore, but it's still not that much more difficult to set it up, is my hope.
Okay.
And now you can do whatever you want to solve this. You can do elimination, substitution. Which one do you want to do? You could even, if you wanted to, what's kind of ugly about this one? The decimals. So how could you get rid of them?
Times it by 10?
Yep. Well, multiply by 100. So then you make, so 2 now becomes 25Q plus 10D equals 750. And really, look at this. What does this mean? 25 cents for every quarter, 10 cents for every dime. That's 750 cents total. Right? That's what $7.50 is. Okay, cool. Maybe. So which method do you want to use? Substitution. So what would you do to substitute?
Get a variable by itself.
Which variable do you want to solve for? And why am I picking this equation?
Because they're already by themselves.
Because there are already ones in front. I'm not going to pick up any fractions, right? So solve for dimes.
Yeah.
So subtract the quarters. So hopefully, and from what I remember on the test, pretty much you either get it or you don't with the algebraic solutions for systems of equations. Substitution, elimination, you either get it or you don't. So if you don't quite get it yet, you need to come see me so I can get you into the get it category. So again, it's safe enough for me to say, once you get a word problem set up into an equation, that should be the easy part now, right? Setting it up is the hard part. Now I just use elimination or substitution. Where can I put this here? I'll tell you where you can put that, Jeff. Don't say that. Yeah, this goes where the D is. That's the whole reason we call it substitution. So now I got 25Q plus 10 times D.
39 minus
39 minus Q. And just to let you know, on a lot of these problems, you will end up getting some of these larger numbers. Do not let them trouble you. Just put it in the calculator, whatever it is you got to do. If you had to, you could do it by hand. Don't do that to yourself. I got enough other stuff to worry about right now. Good. So 25Q minus 10Q, 15Q. Subtract the 390.
Excuse me.
Yes, sir.
The second equation is 0.2 25Q plus 0.10.
That's right. D.
When we multiply by 10, it's only 1.
I'm sorry?
When we multiply the second one by 10 to cancel the decimal.
Yes, we multiply each one of them by 100.
It's 1D.
Well, you could write it as 0.1, but still, how do you make this decimal go away? You multiply by 100. Can you multiply each thing by something different? No. You got to multiply each thing by the same thing. So it's the one that needs to move the most that rules. He says I got to move twice. And what he's saying is you only have to move this one once, and then it's the whole number. But you got to move him twice. And you got to do the same thing to the whole equation. Good. So down here you get 15Q equals 360. And then you divide by 15, you get, what's that? 24. So what's that by itself mean? This little kid has 24 quarters, right? So he's got 24 quarters. How many dimes does he have? 15. Cool. 15 dimes. How you guys feeling about that? I mean, it's word problems, but it is nowhere nearly as bad as the original word problems you had to do. Okay, all right, maybe. So here, you guys try this one. Let's see, go to a fair. Adults cost $7 each. Kids cost $3 each. There are a total of 1,100 people. All right, Jeff, you gotta make it work now. That'd be useful. And there's a total of $5,700 collected. I think. Let's hope. That's all hope. Yeah. Okay. So figure out, I want to know how many adults and how many kids. And as always, it is not okay to guess and check. People go, oh, there's 400 and 700. No, it doesn't work. Let me try it with me. That's not algebra. This is why we're here. What's up? Not missing anything. It doesn't seem fair for a problem that takes a relatively long amount of time to solve. It doesn't really take that long for me to set it up. That's too bad. So let me ask you this, if you're having some trouble setting this up, if 10 adults came, and they each had a kid, so 10 adults and 10 kids, how much money would I collect that day if only 10 adults and 10 kids? 70 and 30. That number is the thing I actually don't know. So there's going to have to be an equation that includes that idea, 7 times something plus 3 times something, because that's what you just did with the 10 and the 10. Right? In fact, if 10 adults and 10 kids came, how many total people would that be?
I was in
20. 10 and 10, 20. Right? So I've got to have some idea of adding the people up directly and then multiplying that by the money so I can get the money. So what are my two unknowns? What are my two variables? A and K, I love it. So A is the number of adults. K is the number of kids. Now, where's that number 1,100 come from?
A plus K.
Yeah, A plus K. I've got to add up the people. The adults plus the kids better equal the total number of people that came. Well, something freaky's going on. So I got adults plus kids have got to equal the 1,100 people I saw come. Now, how much money do you collect from each adult?
$7.
$7. And then how much money do you shake the kids down for?
$3.
$3 each, right? Or else they have to stay outside. And how much, now, so the $7 per adult plus $3 per kid, that should give me the total amount of money that I actually made, which was $5,700. As long as I did this right in my head, this should actually work out. Yes, sir.
I got both of the same equations, but I just got 2 on top. I mean, I got 2s and 1 and 1 and 2. Will that matter?
I'm sorry, say it again.
Like, for example, I got the same equation.
Oh, yeah, no.
Doesn't
It
matter?
doesn't matter which one you put first.
Alright.
That doesn't matter at all. I'm told 2 different things. It doesn't matter how you write it down. Because the math is not going to care. You could use substitution, you would just substitute in the first equation from the second, right? Whereas me, I would substitute this, and it doesn't matter which one you list first. That's a good question, though. It doesn't change anything. I'm going to do this one elimination method just because I want to. We did the last one, substitution. Right? How would I do this elimination method?
I saw the first day.
Multiply by -3.
Multiply by -3, I love it. Or -7, it doesn't matter. If you want to kill the adults, you can do that. We've chosen to kill the kids. It's terrible. But this is what you guys want to do. So, multiply by -3, what do I get here? -3a. -3k equals -3,300. Okay. And we did that in order to cancel the k variable out, right? We say that instead of kill the kids, it sounds like 7a minus 3a, 4a. Those cancel. 5,700 minus 3,300 is 2,400. Divided by 4, there were 600 adults. So considering that together with kids, I had to make 1,100. How many kids were there?
500.
Yeah, adults plus kids is 1,100. So 600 plus k is 1,100. So kids, there were 500 kids. Yes, ma'am.
I was supposed to go with the substitution method and I got some retarded answer. Can you do?
How can you tell that the answer, what does it mean for it to be retarded?
It does not seem, it's.
Do you get like a third of a kid or something?
So you had to go like 3 points.
And they would be in the fair, there would be an intent, I think, a third of a kid, I don't know what that is.
Yeah, I don't know.
So you got the same equations though, right? A plus k, okay. And 7a plus 3k equals 5,700. So if I want to do this using substitution, what did you do? What did you solve for?
I solved for A.
A, okay, so you subtracted k here. Like that?
No. That's not what I did, so that might be why my answer.
Where did you solve the second equation? Do you see why you don't want to do that? Because that what did it bring in immediately? It brought in all these fractions. Which, if you had to, I don't want to make it sound like you can't. You should be able to handle it if somebody told you, you must use this equation. If I have a choice, hell no am I going to bring in fractions. Because I don't care how good at math you are, it brings in a more opportunity to make a mistake. You with me? I don't care how good or bad you are at math. So when I have a choice, I'm not going to go down the fraction route. So this first equation is beautiful for substitution, bless you, because I can solve for one of them and not bring fractions in. So now what would you do with this here?
Substitute.
Yeah, put it in for A. A is this. So 7 times A, which is this. And now we've kind of, substitution is more indirect, it's more subtle. It says let's replace this guy. Elimination, let's just kill this guy. So now here you just so you get negative 4k, and I can subtract 7,700, and I get negative 2,000. Thankfully the negatives cancel, so I don't have negative people. That would be equally frequent. So there's my 500 kids. And then again, I plug it in, I'm going to get my 600 adults. You always want the adults to outnumber the kids. It's a good general rule. right? I'm not saying it's how it's always going to come out. So. Do you guys get the idea that they're always going to happen when you got two things you don't know? The number of adults, the number of kids, number of quarters, number of dimes, whatever. The number of assists, the number of points. Could be a basketball game problem, right? If there's two things you don't know, they must tell you two pieces of information. Either directly, like the hot dog problem I had up here before. 4 hot dogs and 5 French fries and whatever. That's very direct. 4H plus 5D. 7H plus 3D, whatever the hell. With me? Or they got to tell you the total number of things and the total cost or something, two separate ideas, so you can set up two equations. This is the only way to solve for two variables, two unknowns. I've got to have two equations. If I had 3 unknowns, I would need 3 equations. If I had 80 unknowns, I would need 80 equations. How far are we going to go?
2.
Not 80. 2. In math 110 or 103, you're going to go up to 3, and that's as far as you go. Up to 3 equations with x, y, and z in it. Yay. Here, no. We're not going to do that yet. Okay. So tell you what. I've got one more section I really want to do, and then a little bit of a preview of the next section. So if we just forge ahead, we can get out a little early. We won't need a break. How you guys doing? Can you do that?
Yes.
Maybe I just energize a few of you guys. We said get out early. I can make that. All right. All right, so here's a little review. And to save space on your, I'm sorry, I just kick you over. To save space on your paper, I want you to graph both of these on the same coordinate system. Oh, cool. So let's see if you remember this. So this is like 2 separate problems from that section, where was it? The last section, chapter 3, I think it was. You guys remember that? So if you didn't like that section where, remember what you have to do here, graph the line and then shade one side or the other, make sure the line is the right kind of line. If you didn't like that, you're really not going to like this next section because you got to do it twice over. So here's the thing. Do that one all the way. And then on top of that one, do this one all the way. Yep. Call me if you need some help. Look for somebody sitting near you if you want to.
I've seen it before, but sometimes the words don't really match the voice.
So it might not be.
It has to
Might
be
be more
really
of a
clear word, yeah.
If it's a key word, they mess up in the speed.
Yeah.
Because that's the missing, I like the video for people to see.
Wait, why would you
The
get
thing
that?
I'm missing is
Closed
captioning,
caption,
yeah.
yeah. Yeah, I heard
What
there's
if
some
it's your
programs,
line or
but
substitution?
I saw one that was like, those words are missing.
They're probably just Spanish. Well, Google translates that
When I
online.
was up top, and I was like, wait a minute.
Early going, I translated the page into French. I showed some friends of mine who were French, and they were laughing because the grammar and everything was totally wrong. You know.
So it's down.
They got a lot
one?
better.
Down 1 over 10.
Down, yeah, down 1 to the right of 2, I think. So that's true. I think. Oh, gotta make sure it's the right line too. The first one's.
We graph it on the same.
Yeah, you're supposed to graph it on the same graph. So I
Same
think-
graph.
No.
This one solve for don't overthink it. You're thinking it's all, but it's a lot of times these problems.
Okay, now what?
It's all, it starts off, so you get.
I'm confused.
I did it, but I don't know what.
I'm trying to shade the second one right now.
Oh, you have to
So
change
this
those.
is 1 and this is 2. I assume so. This is 2. Just 1, 0. I mean,
Each one by two. And let me show you how to do it. So to put it into MXSP format, I'm gonna put this first. So I can see the MX, and actually I'm gonna write it out like that. And I can
yours
see
looks the
the
same as mine,
MX.
as far as the graphs go.
So I pretty much force my X to be first no matter what, so it matches that. Right. So what's the Y intercept? Good. Make a little.
You're supposed to shade both of them.
Oh, yeah, you're supposed to either shade all of this. Or
So then something's gonna happen like both of these 2 are shaded.
Y intercept two.
I don't think so.
Now, slope tells you to go -1, down 1, over 2.
Maybe it's parts that aren't shaded.
Now, connect this. It's a solid line, because it's equal. Test point, you plug in 0, 0. Does it work? 0 less than 0 plus 2, 0 less than 2. 0 less than 2. Yes, so then you shade that. Me, I always look and say, this is Y less than, so I add it down. Now you try to do the other one, solve for Y, and then try to put it on top of that. Sure.
Is that the equations you guys got?
Yes.
Okay, cool. And again, if you have your own way of doing it, if you find the intercepts or something, that's fine too. I just really stress doing it this way. It just, you need the practice of the MX plus B to know what those mean. So the first one, the y-intercept is 2. So there's 2, and then the slope tells me to go down 1, over 2, So there's my line there. It's a solid line. Why?
Or equal to.
Well, it has the equal to sign in it. I'm with you. The second one, what's the y-intercept? 3. And the slope tells me to go up 1 over 3. It's also solid for the same reason. Oh shoot, I forgot to shade this guy. If I do a test point, and actually that's easier. This is more than just directions. This is the way to do this. Totally finish one of them before you start the other one. So don't do what I just did. I forgot the shading here, right? So if I do a test point, is 0 less than or equal to 0 plus 2?
Yeah.
0 less than 2? Yes. So I'm going to shade in the direction of 0, 0, because that test point worked. When I graph the other line, I didn't have to totally get rid of it, Jeff. I think it was right there, right? 1, 3. Which way am I going to shade for him? Is 0 greater than or equal to 0 plus 3? Is 0 greater than 3? No. So I'm going to shade up. This is a little bit of an evil example. The answer is where those two shadings meet. Isn't that going to be right in the middle of those two? Do you see that? Because it's got to be below this line and above that line. Where do they meet? So here's the answer to a system of linear inequalities. Good God. So this is a system of linear inequalities. The answer is where the shadings overlap, where they cross-hatch, if you like that. Right, so if I shade up from this line and down from this line, where do they overlap? Right in here. So just kind of make that area a little darker so I can see it. Do you guys get that? Hold on. If you're able to do each of these on their own, right? So here's what this is used for in the real world, by the way, plus a little bit of an easier thing to look at. If I have a restriction, this is how it's used in the real world. If I have a restriction that it's got to be below this line and above this line and above this line, where do they all meet? There's a little triangle here, right? That's my safe area. This is what we use it for in the real world. I think I said this back when we first did one line. I said we will be doing a section where we have more than one line. This is my safe area. This might be a load on an elevator. So if you're out here with the number of people and the number of whatever, if you're out here, your elevator has a high chance of plummeting. Bad situation. This is my safe area. Of course, nobody on the elevator's fine. If I have this many of these people and nobody in the other, if I'm right there, I'm fine. If I get up out here somewhere, I'm in the unsafe area. Very often in the real world, these are called constraints. You don't want to have this many people or something on an elevator or whatever situation it's in. Engineers use this kind of thing all the time. Wind force and how much weight there is above and where the weight-bearing thing is and so forth. They say, well, what's the safe area for this? You know, if you build a building in Chicago, you got to take into account the heavy winds and how much sway do you want to build into your building. You can analyze that safe area with something like this. Your equations might be, to be totally honest, might be a little uglier than this, but it's the same idea. It's that area where they all cross-hatch. You say, that's where I can be. That's my safe area. Nobody dies here, right? It's a good thing. So the better you are at that chapter 3 section where we did this one by itself, obviously the easier this will be because it's just two of the same idea. Yes?
So as far as on the homework and on test writing the answer, we just shade that part darker?
Yeah, there's no writing of the answer.
Okay.
It's shade that part darker. Exactly. Beautiful. Let's try another one. We do this one to you a little bit more direct. So I've solved those for y for you. Be real careful when you're solving it for y. If you divide or multiply by negative, you better flip that sign. It's an inequality. I don't care where you are, what kind of problem it is. You better flip that sign. Divide or multiply by negative. Nothing can ever change. You can only learn more. Nothing changes. Yeah.
Do you want us to label which line for which equation, like when we graph it?
It's not a bad idea. In fact, I normally do. Like this was number 1 and this was number 2. Keeps you straight too. If you forgot to shade one, you're like, well, where am I looking for the test point? This line is, oh shit, you know. So that's why I say do one totally and then do the other one. So on this one, number 1, what's the y-intercept? 5. And the slope tells me to go down 4, 1, 2, 3, 4, over 1, 2, 3. What kind of line will it be? Solid. And if I do a test point, is 0 greater equal to 0 plus 5? Is 0 bigger than 5? No, so I'm going to shade which way? Up. I like it. Or away from the 0, 0. Since that did not work, these must be where all the not answers are. That must be the answers. Cool. Yes, I like saying the not answers. What's the y-intercept for the second dude? So we'll call him number